Hello everyone, welcome back to the map of mathematics. In this video, we are going to solve this nice math Olympiad algebra problem. And here we have n cubed minus n equals to n factorial, and we find the value of n. So that here you first know about the factorial. So here we explain first the concept of factorial. So here you know that if we have 2 factorial, then we just decrease it by 1 and we multiply all these terms and we write it as 2, and when we decrease 1 by 2, then you get 1 and you get 2 times of 1. Similarly, if we have 3 factorial, we write it as 3 multiply 2 multiply 1. And similarly, if we have n factorial, so we write it as n times of n minus 1 into n minus 2 and up to so on 3 multiply by 2 multiply by 1. So we extend the n factorial in this way, and in the next step, if we break the n factorial up to the n minus 1 term, then we write this n factorial as n times of n minus 1 factorial. So here you focus on the right hand side of this equation and we replace this n factorial by n into n minus 1 factorial, so that the above equation will be written as n cubed minus n equals to, we have n factorial and we put the value of n factorial and we write n times of n minus 1 factorial. So here you see that we have n be the common expression on both of the sides, so that we divide both of the sides by n. So here we write divide both sides by n, and we write it as n cubed over n, n over n, and n into n minus 1 factorial over n. So this implies that this n is cancelled by this n and we get n minus n square minus 1 equals to, this n is cancelled by this one, and here we get n minus 1 factorial. So now in the next step, first you focus in the left hand side, and here we have n square minus 1, and here we use the square identity and it will be equals to n minus 1 times of n plus 1 equals to n minus 1 factorial. And now we extend this n minus 1 factorial to one term and we write it as n minus 1 times of n minus 2 factorial. And here you see that we have n minus 1 be the common expression which is lies on both of the sides, so that we divide both of the sides by n minus 1. So when we divide both of the sides by n minus 1, so it will becomes in this form. And here you see that this n minus 1 is cancelled out by this n minus 1, and this is cancelled out by this one. So after dividing n minus 1 and make simplifications, we get here n plus 1 equals to n minus 2 factorial. So here we need to write this into the simplified factorial form, so that here, in order to convert this into simplified factorial form, we take here x equals to n minus 2. So here we take this value equals to x, and this implies that when we move this minus 2 in the left hand side, then we get x plus 2 equals to n. So we put the value of x in and n in the above equation, so that the above equation will be written as, here you have n plus 1 and we have n equals to x plus 2 and plus 1 equals to, we take n minus 2 equals x, so it will becomes x factorial. So now in the next step we have some this equation will becomes in the form of x plus 3 equals to x factorial. So now here we find the value of x by inspection. So here we substitute some values in x, and we check that which of these values of x are satisfied by this equation. So now first we check at x equals to 0. So when you put x equals to 0 on both of the sides, then you get 0 plus 3 equals to 0 factorial, and you know that 0 plus 3 equals to 3 and 0 factorial becomes 1. So here you see that 3 is not equals to 1, it is not possible. And similarly here we check at x equals to 1, and when you put x equals to 1 on both of the sides, then you get 1 plus 3 equals to 1 factorial, and 1 plus 3 is 4, and 1 factorial equals to 1. So it is also 4 is not equals to 1 and it is not possible. And here we put, or we check at x equals to 2. So when you put x equals to 2 here, then you get 2 plus 3 equals to 2 factorial, and 2 plus 3 is 5 and 2 factorial is 2. So 5 is not equals to 2 and it is not possible. So x equals to 2 not satisfy this equation. And similarly we will check here at x equals to 3. So when you put x equals to 3 here, then we get 3 plus 3 equals to 3 factorial, and 3 plus 3 is 6, and 3 factorial is also equals to 6. So here we see that x equals to 3 satisfies this equation, so that x equals to 3 be the solution of this equation. But here in the above you see that we will take our x equals to n minus 2, and we have n equals to x plus 2. So we put the value of x in this equation and we get the value of n. So that here we put the value of x equals to 3 in this equation, n equals to x plus 2. So when you put x equals to 3 here, then we get the value of n equals to 5, because here you see that we have 3 plus 2 is 5. So n equals to 5 be the solution of the given equation. And now we check that is this solution satisfies the given question statement or not. So that here we check it, and we have the given question statement is n cubed minus n equals to n factorial, and here we put the value of n equals to 5 on both of the sides, and we get 5 cubed minus 5 equals to 5 factorial, and 5 cube is 125 minus 5 equals to 5 factorial equals to 5 times of 4 times of 3 times of 2 times of 1, and 125 minus 5 equals 120 equals to 5 times of 4 is 20, 20 times of 3 is 60, and 60 times of 2 becomes 120. So this shows that n equals to 5 satisfy the given equation. So n equals to 5 be the only solution of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.